Series is? I think it's just the same word, series, but anyway. Okay. So let's start by talking a little bit about sequences, okay? So basically what we saw was a sequence is an ordering, an ordering of numbers in a pattern. And the domain for that would be just all the numbers 1, 2, 3, 4, 5. Those are the numbers you were plugging in, right? Domain, that's kind of, we used to call that x, but that's the numbers that you plug into a function or an equation or that sort of thing. And so the domain is just 1, 2, 3, 4, etc., etc. And the range, the output of that would be what the numbers are in the pattern. So you guys were able to come up with formulas for these. So sequences really are kind of like functions then. There's an input, there's an output, right? And so we can make an equation for a sequence if we can figure out what that pattern is and do kind of like what you did was think about if I put in a 1, I need to get this. If I put in a 2, I need to get that. And see if you can kind of work that backwards to see where it came from. So as an example, I think one group had this as a sequence. It might have been the series that they had. 1, 4, 9, 16, 25, etc. So how do you come up with a sequence like that? If I plug in a 1, I want 1. If I plug in a 2, I get 4. If I plug in a 3, I get 9. What am I doing to each one of those numbers to get 1, 4, 9, 16? Nope. Nope. Squaring them, right? If I square 1, I get 1. If I square 2, I get 4. If I square 3, I get 9. So the formula for this one okay, and that's read a sub n equals n squared. So then I might ask you a question, okay, so if this is the sequence, find the 10th term in the sequence. Now, if I didn't have the formula, I could still do that, right? Just keep following the pattern until I get to the 10th number. But having the formula makes it a lot easier because then what can I do? Just put 10 into that formula, right? 10 squared. So the 10th term of the sequence would be a sub 10, right? Because now we're doing the 10th one instead of just n. And that's going to be 10 squared. So the 10th number in that sequence should be 100. So that's why we come up with these formulas, is because if I want to know something about a sequence down the line somewhere, I can just plug into those little formulas and I can get it that way. Okay, so the first term is a sub 1, the second term is a sub 2 all the way, so the 10th term is a sub 10 when we do that. Okay, so two different kinds of sequences that we're going to look at. Finite and infinite. But do you know what those two words mean?
The same thing.
Nope.
Opposites.
How are they opposites? Okay. Finite is something that ends, something that's countable. So like if I had a sequence that had 6 terms in it and then it stopped, that'd be finite. Okay? 1, 2, 3, 4, 5, 6. Done. There's my sequence of numbers. I want to stop after 6 of them. It's finite. Infinite is kind of like I have up there, the 1, 4, 9, 16, 25, because it keeps going and it won't ever stop. The way that's written with the dot, 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 dot at the end there, that means just continue doing this forever. Okay? So, finite essentially has an end. And infinite continues forever. Okay, so we'll look at some. Both of those, though, you can come up with a formula like we did here. There's going to be a pattern in there somewhere that you're going to use. And so you can follow that pattern to the end in a finite one, or you can continue that pattern as far up as you want to go with an infinite one. Okay? So, as an example, let's say that we have a formula a sub n equals 3n minus 5. And let's say it's defined for n between 1 and 5. So then write the sequence. So this is kind of doing a little bit backwards of what we did in the activity. Instead of you having to come up with the formula from the sequence itself, now you have the formula and you have to write the sequence. This is easier by far. What's the only thing you need to do here to come up with this? Just plug in the numbers, right? You have 1 through 5, plug them in, start writing out that sequence then. Okay, so if I plug in a 1, see if we can do this math in our head real quick. If I plug in a 1, what do I get? Negative 2. If I plug in a 2, careful. Nope. Positive 1, right? 6 minus 5. If you plug in a 3, 4, be 9 minus 5. If you plug in a 4, so yeah, he's on it. Now, did anybody catch the pattern as we were writing the numbers down there? You're adding 3, right? Okay. We're going to talk a little bit more about this tomorrow when we talk about arithmetic series, because this is arithmetic sequences. This is a type of sequence called an arithmetic one. But notice how the difference of all these numbers was 3, and there's a 3 right here. It's not a coincidence. That's always the same in the formula and how you add them up. Okay, so that's doing that. Let's talk a little bit about series then. All right, a series, the only difference is as you go along, you're adding up all the terms. Okay. With a series, we'll have that series written out with all the plus signs in it, and you might be asked a question like, okay, for this series, what is the sum of the first 4 terms? So then you'd only plus up to the 4th one. Or what is the sum of the series up through the 11th term? So you'd add the first 11 terms of it all together. So a series, it can be finite. It can be infinite. Those get kind of crazy. We won't talk much about infinite series because then you're adding things all the way up to infinity, and that's kind of a mind bender, but it can happen. So we'll deal with just finite, but you're going to have to know what the pattern is, and then also how far do I need to add it up. Okay, and it's got this really funky notation that's called sigma notation. That looks like this. Okay, so here's what everything means in here. Down at the bottom, now we're going to usually just start at 1, but you could start anywhere in the series you want. So maybe I want to start with the 5th term and then only add up until I get to the 13th term or something. So this is where you start. Okay? So n equals 1 is usually what you're going to see because you're going to start on the first one. Up here on the top, this is where you're going to stop. So I'm going to go from this number up to, so normally this is a number up here. So from this number to this number up here, and then this is going to be the formula that you were using to make your pattern. Okay? So let's jot that stuff down. We have that in our notes too here. So this is going to be the start. This is the finish. And this is the formula. And the reason that this thing is called sigma notation is just because this is a Greek letter, sigma. So don't really need to know anything more than that. Okay? So let's see if we can take a series that's written in sigma notation and actually evaluate it. Add up all the terms that we're supposed to and put it together. Okay? All right, we'll do that on the next page here. Whoop. Huh? Mr. Bergman. Okay, so let's try that. So we're going to start at 1, we're going to go to 4, and we're going to use the formula I plus 2. It's a 1. So what this means then is you're going to have 4 terms you're adding together, right? When you plug in a 1, when you plug in a 2, when you plug in a 3, and when you plug in a 4. Add those up. Okay? So what plug in a 1? What do we get when we plug in a 2? Okay. So it's a complicated looking little formula thing for really something that's pretty simple. 3 plus 4 plus 5 plus 6. That's all we have to do for this one. So 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18. So this one comes out to 18. Okay. Everybody catch how we put that together? And you have to add it all up, right? Oh. Nope. All right, let's try another one. The sigma? It's kind of like doing an E with a... Oh, sorry. What can I do? Stupid Greeks. Alright, let's do I minus 1 squared for this one. You guys ever see the movie Starship Troopers? It's like the alien from Starship Troopers. Anyway. Yes, but let's move on. Okay. So 3 is the first one we're going to plug in. Alright, so if you can't do the math in your head, write it all out. That's fine. I'm going to see if we can do the math in our heads here, though. So if I plug in a 3, order of operations, 3 minus 1, 2, 2 squared, 4. So the first term is a 4. Next one I'm going to plug in a 4, 4 minus 1, 3, 3 squared, 9. Next number is a 5. Gives me 16. Maybe you're seeing the pattern. Now the question is, though, when do I stop? But I'm actually at 6. Because it's I minus 1 squared. So this is at, so the next one would be 36. That's plugging in a 7. And then 49 would be the last one if I plugged in an 8. So 4 plus 9 plus 16 plus 25 plus 36 plus 49 would be that series. That one, go ahead and use a calculator. That's fine. We are stopping at 8. 8 minus 1, right? Minus 1, then square it. What? Shh, guys. Shh. Quiet, please. You had a question? What? You okay? Okay. Just see me later if you got a question, I guess, then. Did we get these all added up? 139. Okay. All right. That is everything that we need. So I'm going to let you guys start working on your homework. We got about, what, 10 minutes?
Can we shorten it a little bit? I got a long night.
That's why you got the late passes if you need them. So.